Hello everybody and welcome to the Expressions and Statements lesson from the SoftUni Programming Basics with Java training course. In this talk, I will explain you about variables, data types, operations and many others, which will continue your first attempts to learn programming and will give you additional skills to extend the knowledge from the previous session that we had in the previous time. So what I will cover today, my name is Svetlin Nakov, is variables, how to declare variables, how to read variables value, how to modify the current variable value, data types and the different kinds of data types, like numeric types, like integer types, real numbers, fractional numbers, and handling data types holding variables like characters and strings. Later, I will explain you about the statements in programming, or the so-called commands or actions, things that execute or do something. Later, we will go briefly through the topic of reading input from the user and formatting output from the console. Just like if you want to enter some value in the program to process it and to output some result, you will need input and output, like the Java util scanner or some different method of reading user input data. I will talk about simple operators like plus, minus, multiplication and divisions, and later I will combine these operators along with constants and some literals and values together to use expressions. Expressions just like in math, but in programming we can have string expressions, numeric expressions, and other expressions. Finally, we'll have practical exercises where you will write code in order to learn really the practice of everything we have mentioned in this training session. Okay, let's start with this. So the first thing we need to introduce today is the so-called variables. Variables as means of storing and processing data, as memory locations which are given a name, and these locations that hold some data which can be modified later. So how does computing work in general? Computers are machines that compute, machines that process data. So computers are data processors. They take some input from the user, from the keyboard, from the mouse, from the microphone, from the joystick, from the internet, whatever, and they process this data. For example, they take data holding a video stream, they process this data, visualize this stream or video on the screen, and finally they output something like display something on the screen, or print something on the printer, or send something over the network, etc., etc., etc. So computers are computing machines. They work with data and they hold instructions and data, and both of them are stored in the computer memory. Computers have memory, and this memory holds data and holds their programs, their instructions, their commands, which they execute one by one and to do their job. So data is stored in programming using variables. Variables are named locations of the computer memories holding certain value. So one variable is located at certain place in the computer memory. Other variable is different at different space, at different place in the memory. So variables are containers for data, containers for information, a named area in the computer memory, and the data can be read and can be modified or changed at any time. So the memory, also called RAM, RAM, read random access memory, which means that you can access the memory at random locations and you can change it and process it at any time. So variables in programming provide means for storing data like person name, like account balance, such data, and they can retrieve this data by the variable name, and they can modify the stored data for later use. For example, if I need to open an account, I will store the data about the account in the computer memory. Probably I will store this in the database also on the server's hard disk, and later I will retrieve back this data and will modify it, for example, when I pay something. So variables are characterized by name or identifiers, for example, username or password, or it can be account or account balance. This is the name. They have type of the information preserved, like their type can be string, can be text, can be date, can be picture, can be video or other type, and they have value. The value is the actual data stored inside this variable, which may change over the time. So this is the syntaxes for defining variable in Java. In Java, I can say int age equals 25. So this int is the data type, this age is the variable name, and this is the declaration, and then follows an assignment or initial value which we give to this variable or which we store in this memory location. So variables are named areas of computer memory, and they store a value from particular data type. For example, integer value or numerical value or text or date and time. And variables values are accessible in the program by the variable name. So if I have a variable called student, which holds the name of the currently logged in the system used student, I can access the student name by this name student, by the variable name. So variables can be stored in the program's operational memory in the stacks, in the execution stack, like integers do, like floating point numbers do, or in the dynamic memory, like when we hold texts and others. The dynamic memory can be changed over the time it's sized. So operational memory is usually used for fixed size variables, which are small. This is the so-called execution stack. The dynamic memory is related to the so-called pointers, variable holding address in the memory, which holds the actual data. We'll talk about this later in our trainings at SoftUni, but I just mentioned them now. So let's show you variables. I will start the IntelliJ IDEA, our favorite integrated development environment, and I will create a new project especially for today's lesson. Today's lesson is about data type, variables, and calculations. I can name the project calculations or something like this. It's starting very slowly, I don't know why. But it's time to drink a small coffee. Okay, please start. What happens? IntelliJ IDEA is starting. It shows a sign of starting, but still not started. Did you see the image below the so-called what is it? The starting screen. It's still starting. I cannot believe. My laptop is truly fast, but this is incredible. How slow is this? Okay, finally it started. So I create a new project with IntelliJ IDEA. I click create new project. It will be Java. I use Java 12 configured, and I click next. Then I say, please create a Java Hello World application, and this application will be named calculations examples, because today's session is devoted to calculations or calculations examples. Okay, I will finish this, and it will take, I hope, less time to finally have this project and being able to write some code. Okay, so I have a project here which holds one class in the source called main.java, and in this class I have a few lines of code. Okay, so let's go with variables. Int age is 20. So console write one s out system.out println this age. If I run this application, right click run main, I will see this age 20. Okay, it's slow only for the first time. Later everything is cached, pre-processed, and it's no longer slow. But okay, this is the age, so I can print also age and this age. Run it. Okay, so I can print the variable content like this, age 20. So, but later I can say age is 21, and I can print the age again. It will be the new age, which shows you that the variable value can be changed over the time. I click Ctrl F5, so it says first the age is 20, later the age is 25. I can run this through the debugger. I will put breakpoint like this, and we'll say debug. Okay, and now the program will be executed one by one, and I will show you how variables work. So I have int age is 20. I press F8, and now but let me see. Yeah, these are the values here. These are all the variables here in my program. I can have hundreds or thousands of variables. When I print it, it will be printed. So the output is like this. Okay, when I go at the next line, I press F8. Now the age is 21. It just got changed. Its value got changed, and I print this variable, and I have the output here. So this is how it works. I can just stop this debugging session and stop the program execution and this debugger session. Okay, let's go ahead. I explained you that the variables are named areas of computer memories which store data which is accessible, and it can be stored at different locations, but this depends on the type. I'll show you another example, string name. Okay, name is Svetlin, for example. So I will print the name of the person, then I will say name equals to, for example, Mariah. I change the name and I print the changed name. Very similar, Ctrl 5. I believe we'll do the running of the execution of the program. So it's first name Svetlin, then name is Mariah. I can run it through the debugger or without the debugger, but it's not quite important. The important is that I can have variable, it should have a type, and the value is on the right. Instead of this, I can put var. Var means that the variable will have the same type like the assignment expression at the right. So this is a string, okay, and this name is of type string. This will work again. This var syntax is only available in the latest Java versions. It was introduced in Java 12 or 11, I'm not sure. Okay, let's go ahead with data types. Data types are, in short, the ranges of the variables, of the values possible to be assigned to certain variable. I will give you examples. So the data type variables can store value of certain type. For example, here the variable type is string. If I try to assign something like name is 15, this will not compile. It will say, oh, we have incompatible data types. We have variable of type int, and you are trying to assign, you have variable of type string, and you are trying to assign a value of type int. It's not good, it's not possible. Or if I try to assign 15.4, it's a value of type double, a floating point number, and I want to assign it in a variable of type string. This cannot work. So variables have type, at least in Java, and in Java the type is explicitly given, explicitly explained, and variables cannot change their type over the time. In some language we can change the variable types over the time, like in Java or Python, but in Java, like in JavaScript or Python, but in Java and C# we cannot, because these are strongly typed languages. So variable type can be a number, or letter, or text, or date, or color, or picture, or a list of something, or a list of images, or it might be a count, it might be many things. But types define the range of the possible values. For example, if the type is integer, it should be an integer, a whole number without fractional part in it, and it has a certain range. For example, the int type is from -2 billions to 2 billions. Data types like int are integers, just like 1, 2, 3, etc. Double is a floating point number like -0.5 or 3.14. Boolean is a special type which can hold only true or false, yes or not, agree or disagree. This holds a Boolean condition, whether something is true or not, or where something happened or didn't happen. Char holds a single character, single letter, for example, A, for example, B, for example, the dollar character, or the question mark, etc., etc., etc. And strings hold text, like hello, like just a word, a sentence, or a whole book can be put in strings. Strings hold texts. So we'll work with strings later in our next training course called Programming Fundamentals. Okay, so data types might be defined sets or ranges of values with similar characteristics, like numbers, like dates, etc. So data types are characterized by name. Data types have name, like Boolean, like int, like string in Java, and these are related to certain Java keywords or classes. They have size. For example, the int type is 4 bytes. The Boolean type is 1 byte only, just 1 byte. Okay, some string hold 4 plus variable number of bytes. For example, if we hold a short message like hello, it will be something like 10 or 12 bytes, something like this. If we call one book, it might be megabytes, it might be thousands or millions of bytes. So strings are variable size variables, and they are kept in the so-called dynamic memory. Variables have default value, like for example, if we have integer and we don't assign a value, it will be 0. If the compiler allows this, because in most cases it will just say, oh, it's an error, please don't do it. Okay, I will give you examples with the other types. For example, Boolean, valid, says, for example, true. This is valid. Is it valid? Yes, it's valid. Later I can change the valid to false. For example, new value as the so-called valid. Is it valid? Initially true. I started the program. Later it's false. Okay, valid true, valid false. But I cannot say it valid plus plus. It's invalid operation. Or I cannot say valid is Peter. It's invalid operation. Okay, it will not compile, it will give errors, etc, etc, etc. So it says I cannot assign to a string value to a Boolean variable, something like this. Okay, other examples are, for example, date. So I can say date d is equal to new date of I'm not sure whether I can create a date from year, month, and date. This is deprecated, but it will do the job. For example, something like year 2019, month, and this, and I will print the date. Just an example. This is not the correct data type for date. I believe it should be local date. Yes, this is the correct new local date. But this doesn't work. It should be I don't know how to work with dates with Java. Dot from dot of date of year, month, day of month. Finally, looks like I managed to learn how to use the Java time local date. So this is a date. This is something which we shall use if we, for example, program ERP system which will hold the orders in online e-commerce website, for example. So I cannot change the date like date plus plus, but I can say t dot at or t dot I should see how to work with this, but t dot plus days of 1. D equals to d plus days. Please add 1 day, and the new date will be something like after the 3rd of January. The new date is 4th of January. Just an example. Okay, so this is to get the idea that we have different data types like date, like text, like number, etc. And this is a normal. We have the same in the spreadsheet, in Microsoft Excel, for example. And this is something normal if you have a table of holding some data. It might hold different data like the purchase date. Like, for example, if you have an invoice have a date of the invoice, which is of type date. It has the company name of the supplier and the company name of the buyer. It has also the ID number, which is usually some kind of integer, etc, etc, etc. So let's go ahead after the data types to statements. Statements which are commons in the computer program. They are the basic units which build our programs. So one statement, it's one command, but technically it's called statement. If you learn a new language, you will see that we have statements, we have expressions, we have conditional statements, we have whoops, which are different kind of statements, etc., etc., etc. So the actions that a program takes are expressed as statements. These statements or commands or actions include things like declaring a variable, like int counter semicolon. They end with this semicolon, which says this is the end of the statement. There is no more things coming after that. No, this is the end of the current statement. So a next statement is coming after that. Assigning a value is done like this. Variable equals to value. Declaring plus initializing might be combined like here. So we have int counter equals to 1. This separately is very rarely used, almost not used. This, this one here is what we usually use in programming. Another kind of statement is a method invocation or command, or how to say, action invocation. Please find the class system, find its output, and invoke the println method and pass as a parameter this counter. So it's a kind of a statement which says, please, which consists of several parts, of several actions. Please find the system. In the system, find the output, the standard console output, and then tell the output to print something and give this something as a parameter. This in the brackets, values given in the brackets are called parameter or parameter values. So another statement is to modify the value counter plus plus, and another statement is to calculate an expression just like this, a plus b, and assign the output, the result of this expression, here in the variable. So I will show you all of this. First, I can declare a variable. For example, int I. If I try to print I, this will tell me, oh, this may have not been initialized. If I try to run this program, it will say, sorry, you are trying to print something which does not exist, which still doesn't have a value. So I should do something like int a is 10, or declare a, and later say a is 10. And then I am able to print it. So I can run the program with pressing Ctrl F5. Oh, and it says it's 10. I can also combine this int a, the declaration and assignment, and do this. I can print many commands, just like instead of system, I can do something else. Like I can say, for example, process dot new process dot something. So I will create a new process. This is more complicated, but I can try something like system dot, it has exit. I can say, please system, please exit, and the return status code is 0. So if I exit the system before printing I, the program will stop before printing I. So the concept is that we have object, some object dot some action, and this is the action. Or it might be like this, object dot sub object dot action, and after that we have brackets and we have some parameters. This is how statements are usually constructed. So I may have system out, not println, but these are the possibilities here. Dot append, please system dot out dot append of this character, and then system dot out dot println I. Now if I run this, it will stop here. I will delete this one, but now it should print $10 because it first appends at the output of the current process here at the standard console or terminal. It prints something, then it prints something else. Okay, so modifying a value I++ or I equals to I multiplied by 2. So we have here I will be 11, then I will be 22. And this will print $22. Let me check. Works. So another thing I can do is to say int sum is equal to I plus b, where int b is 20. So I have 10 plus it's 11 plus 20. The sum will be 31. Let me check. Is it $31? Yes, it is. So this is how different statements work. This is a declaration statement with assignment. This is a method invocation statement. This is a variable increment statement. This is a variable declaration statement. This is a statement of variable declaration plus assignment, which holds an expression. And this is a printing expression. I may have more complex expressions like for, which says int x is 0, x less than 10, x plus plus, and this prints x for each x from 0 to 9 or from 0 to 10. It's like this. So this is a complex statement holding a nested statement inside it. Did you see the output? We'll talk about whoops later, but we may have a group of commands closed into brackets, and this for will execute this group or set of commands here. So see the output. The output will be 0 hello, 1 hello until 9 hello. So we have many commands to be repeated. This one is a composite statement consisting of several statements inside. Okay, so all of these types of commands in the Java language are called statements. They are just the commands we use when we program, and we have statements in any programming language, in Java, in JavaScript, in Python, in PHP, etc. So the next topic I will talk about, it's about reading the user input and printing at the output, formatting the output. This is something which is usually related to the place we take the input and output from. We'll use the so-called console or the so-called terminal window or the standard input and output. This is the standard location where data comes into a certain program and where data is printing when the program prints something. So what is the console or terminal or the standard input output? This is this window, okay? Or also this window. This window here is called the console. I will show you. If I run the Windows console, which is called command prompt, CMD, I can put something and it's trying to execute my commands. If I write something which is very long, see what happens? It directly goes to the next line. Do you see? This is a standard way that it's supported by the console. So I'm trying to enter many things. If I print many things, the console I'm trying to, okay, it's trying to execute the command, but see what happens. The console has a scroller and it might change the information displayed. So it may hold more information than the screen can hold. Do you see? So I have a scroller. This is a standard concept in computer systems, so I believe you will catch the idea. The console is usually holds this black background, but sometimes it looks like this. Or I may have this terminal, which is also a console. I can write commands like dir, which displays the content of the current directory, or exit, which closes the console. This is the so-called terminal. Okay, so this is the console. I mentioned the concept. It's a special window or piece of the window used to communicate with the user. It's very important that the console is text-based, is based on printing something at the command line interface CLI or at the console or at the standard output, and reading text. It displays text data or text-wise, and it reads input, which is also text. The console is always text. It's not possible to print an image or play a video at the console. It comes from the time where the computers were just taking some text input and printing some text output, and they were unable to play video because they didn't have so high quality screen with so many pixels, and they were unable to display an image or also to display to play a sound. So the console and console applications will be our start. Later we will write further in our trainings at SoftUni. We will write web applications, mobile applications, and applications which have different input interface and output interface, like the screen, like the web browser, etc., etc., etc. So our training course called Programming Basics with Java will use the standard input and output console or terminal window, this which is in Java represented by system.in and system.out. How to read something from the console. We already know how to print something on the console out println, but how we can read, we should first know that everything we read from the console comes as a string because it's a text. So if we want to read a user input, we should use this system.in. But system.in gives you the opportunity to read the text coming from the console letter by letter. You usually don't want to read the input letter by letter, but you need the output one by one. For example, if you want to read a person's name, you don't need the first letter, second letter, third letter of the name, you just need the name. So this is the way we do it. We write this line of code, which creates a scanner. It's a kind of specialized text reader for text, which is connected to the standard input for the current process, for the current program. Okay, so it's something like int I equals 10, but this is not int, it's a scanner. We give some name, like scanner with small letter, equals to new scanner, and this is called a constructor invocation. So please create a new instance of this scanner and connect it to system.in. Just remember this, it's always the same. One day you will learn about classes and objects and you will learn better how this works, but just assume it's like this. Once you have the scanner, you can say scanner dot please read the next line from the input. And everything we print on the console is also converted to string. So we say print system.out.println. like hello world, and this is a string. Strings in Java are given in quotes. So we can produce strings using a string expression. This is called a string expression. We have a string and we combine this string with this integer number, and the result is hello123. It's another string, but it's string based. The console is string based. Okay, I will show you how to read from the console. So it's something like this. Scanner scan equals to new scanner of system.in. Please, the system input, read it, open it for reading. So I will say scan.next line, and this returns a string. String input equals to this, and I can as out system out println of this input, and I will say input from the console was this input. I will run this program and it will stop and will wait me to put something like hello. It says I read from the console the word hello. Or I can say today is sunny day. It reads today sunny day. So this enters in this variable called input. I can even say something like please type something, just to tell the user that he needs to type something. Please type something. Okay, something. Okay, something. This is what was read. So this is the way we read from the console, and this is the way we print at the console. We already know this. We can read the input and print it 3 times. So now I will print something. I'm happy, and the computer prints I'm happy 3 times. Something like this. Okay, so this is generally how we read user input when it comes as a text. But sometimes user input is not a text, but it's a number, or it might be a different thing. But first, let's go ahead about the formatting output. I can print something like John is 19 years old. I can do it like this. Let me show you. String name is John. Okay, int age is 19. So I can print that John, the name, plus is plus age plus years old. See what will be printed. Okay, John is 19 years old. Maybe I need to have 1 space here additionally. And now John is 19 years old. But I can print this differently. System.out.printf, print formatted, and I will use a pattern with placeholders, and it will be someone is some decimal value years old, and I will print the name and the age here. See, the result will be very, very similar. John, this percentage S, will be replaced by name. You see, this name will go here at the first placeholder, and this %d will mention age, the second placeholder. Okay, so this is how this works. Let me show you. Percentage S means placeholder for text. Percentage $t is placeholder for integers. And there are other placeholders, but we'll mention them later. Percentage $f is placeholder for floating point numbers. And we can also format this floating point number like this, %.2f, which means print a floating point number just like with 2 decimal points, with 2 digits after the decimal point. I will demonstrate this to you. So I may have a double value. Double size is 20.5. Size is equals to size divided by 3 by 3. And now print the size is, what's the size? Okay, see what happens. This will print the size, but it will format it like this. I want just 6.83, just to cut, to use the first two, exactly 2 digits after the decimal point. So I can print something like this. Print f, the size is %f or %f, and comma the size. See what happens? It will be the same. But when it's not the same. It's by default it's formatted different. But I can say .2f, which means exactly 2 digits after the decimal point. See, if I print use .3f, it will be 3 digits after the decimal point. Even if I don't have 3 digits, zeros will be given here. See, 20.500. I can have this, or I can have something like 0f, which will be just maybe 21. Yes, it's rounded to the next number. If it's 20.4, it will be 20. It has rounding, like 2075.9 with 2 will be 20.76. Can you see it? This is how it works. So this is called placeholder based formatting. You can have a text, you can have placeholders in this text, and you supply values for these placeholders, and they are replaced during the printed with their replaced text. So if I print this 2 times, it will print something which you don't expect. See the first output and the second output, but there is no new line. I can print new line just by println. The first variant, so it will work like expected. I can see something different, for example here with 3 points after, with 3 digits after the decimal point, but I can just print /n, which means a new line. It works correctly, just it's very slow, I don't know why. Or it might be %n, which is a placeholder for the new line. It's nearly the same. So this will also work correctly. So this is the way we use placeholders in Java to format strings. Let's continue now with few more examples about reading the user input. I want to write a program in Java which reads a name from the console and prints it. So this program might be like this. I create a scanner which will read the system input, the input from the console. Later I say next line and I read the next line coming from the input and I put it in the variable called name, and then I print the name. Okay, after that the result from the execution will be something like this. I write some input, for example John, and I get some output from the program, for example John again. I already demonstrated this, so I will go further about reading integers. Reading integers is something like, please read the next line, which is a string. It is a variable of type string, and then convert it to integer using integer.parseInt, and later use this number. Or this might be done shorter with scanner.nextInt, please read the nextInt, but using nextInt, nextFloat and similar might work not like you expect, because they are reading token by token, and if you want to combine reading ones and ints, it might run incorrectly. Be warned. But generally the second way to read integers is shorter, so it's recommended in most cases. This is an example. We are given we want to write a program which is given the side A of a square, and it wants to calculate the square's area. So we read the side A, we multiply A by A to get the area, and we print this area. I will demonstrate this to you. A square area. I will even create a new class here, which will be called square area calculator, because this, what does it? As calculate the area of given square. Okay, square area calculator. I will write the main method with main and enter, and then I will say something like scanner scan equals to new scanner of system.int. It's not imported, so I will use alt enter. It will import the class. It will print import Java to scanner, because I cannot use scanner, it's incorrectly written here, before I import it. If I remove this, my program will not be compiled. See, it's saying that it doesn't know what is scanner, so I need to import it. Alt enter, import class, import Java to scanner, and now it will run, but it will do nothing because it's unfinished. So what next I can do is just reading an integer. Int size equals to scanner dot next int. Please write the next integer, or this scanner is better name. Okay, please read the next input and print something like area equals to size multiplied by size. Because the multiplication has higher priority to addition, to concatenation, first this will be calculated, then it will be here. But it's better to use just int area equals to this and print the area. See, this makes the code more readable, more obvious what it does work, what it does. Okay, so let's run this program and print 5. the area is 25. It reads int next int, returns, if I click with this, it returns int. I use the control and the mouse pointer, and it says that it returns int. Okay, if I use string here, it will say, oh, string and int are incompatible types. You should do a conversion. So another way is to do a conversion. Integer.parse int of scanner.nextWine. Please read the entire next line, and the thing you have read, please parse it to int. This integer.parseInt, this takes as an input a string and returns the integer representation of this string. So if I put here 55, it will be parsed like this. But if I put something invalid like this, it says, oh, I cannot take this as an input. This input string is number format exception. Another thing which can happen is to overflow the integer. It says, oh, I cannot put this into a variable of integer. It's a kind of overflow, but it doesn't explain what's exactly the problem. Or if I put 3.5, it's still number format exception because it cannot be converted to int. If I use as scanner.nextInt, it will behave similarly. If I put correct int like 20, the error is 400. But if I put incorrect string, it says, oh, input mishmash, I have read something which is not what I did. But if I put 20 space 30, it will read the first integer. So next int reads the next integer. If I call it twice, it will read 20 followed by 30. For example, if I have size A and size B, two sides of certain rectangle, for example, I can read something like 20 and 30, and the array is 600. So it just reads the next, or I can put something like 20 space 30. This next int reads one or multiple lines until it finds an integer. And if it finds something which is not integer, like 20, hello, 30, it will fail. It will read 20, then it will take the next token, the next word, let's say, we'll try to read it as integer, it's input mishmash exception, and we'll stop the program. In Java, when something wrong happens in your program, it gives you an error, it gives you an exception. Later we will learn how we can catch this exception and do some different action to handle this exception, but currently we assume that incorrect input just stops the program. Okay, let's go ahead and learn how to read floating point numbers. Floating point numbers are numbers which hold an integer part and fractional part, like 3.14. Okay, so they are read by the type. They are stored in a type called double or double precision floating point number, and they use parse double to be converted from string, it's with capital in Java, to double. And this console scanner.nextLine, this always returns string or text, and this text is converted to double, then it's stored in this variable number. Okay, alternative and easier way to read double numbers is scanner.nextDouble. Scanner.nextDouble just scans for the next token from the input, takes it and parses it to, or converts it to double. This is an example. We want to create a program which converts from inches to centimeters. Like we know, 1 inch, 1 inch, 1 inch is equal to 2.54 centimeters. This is by design. This is the way inch works. Okay, so this is a way to read the inches from the console, and this is the formula to convert it, and this is the statement which calculates inches multiplied by 2.54 and stores the result into centimeters, into this a new variable, and finally it prints this variable centimeters. Okay, I will write this. I will create a new program, new Java class. Programs in Java are stored in one or several classes together. Okay, it will be inches to centimeters, or it might be inches to centimeters converter, because this is a converter, or just inches to centimeters is also a good name. The name should not be too long, because it's hard to read if it takes the entire screen, for example. So it will be, we'll start with scanner equals to new scanner of system.in. Okay, and later, see, it was already imported because I just agreed for the import, and later I say table inches equals to scanner.next table. Okay, and I say var, for example, centimeters equals to inches multiplied by 2.54. I can use var, which is the same like double. It says please calculate this and use the same type like this expression. It might be var. It's better to use double, but just to show you that another way. And these are the centimeters. I can print something like centimeters plus this. Okay, I run this. If I click this, see, it will run the square area calculator. It will run this file. So I need to say, please run this one, inches to centimeters. And it will be run. 5 inches are 12.7 centimeters. Looks like it's working correctly. And if I want to format with 2 digits after the decimal point, what should I print is %f to, it's something, %point to f, and it should be printf with /n, and this should be as a second argument to this printf. Let me check. 5 inches are 12.70 centimeters. Looks correctly, and this was the example. The other way to use this is to have double dot parse, but it's double with capital. This is the class holding double numbers in Java of scanner dot next double dot next line. Next line, see, next line returns string. Next long returns long, etc, etc, etc. So I will use next line, control space. Okay, next line. So let me check whether this works. 3.5 works correctly. I need to mention something important here, and it is that the dot this point is not the default decimal number separator for some countries. Currently, I live in Bulgaria, and in Bulgaria, it's assumed that 3.5 should be written like this: 3,5. For example, 3,5 liters of water, for example. It's the way it's correct in Bulgaria. This is called locale specific formatting. So in Windows, we have formats. Let me see the current date and time formats. If I open, I have the country of Bulgaria, but I use the English formats. And these English formats use different, for example, I use the Gregorian calendar. The first days of week is Monday, in some countries it's Sunday. This is the date format, etc, etc, etc. So if I use regional format, I can use this. No, change data format. It's not this, sorry. Region settings. Here I can change these additional settings and change the decimal symbol. For example, if I choose the Bulgarian default format, Bulgaria. Where is Bulgaria? Like this. Apply. Now, if I run again this program and enter 3.5, it says 8.88 centimeters. So I can input something like 3,5. Oh, the scanner reads something. Oh, it's a big system in double door parse. Double always uses this, but if I say scanner dot next double, see, it should be 3,5 and the centimeters. This is in Bulgaria, the default. If I put 3.5, it says, oh, incorrect. Why? Because I use this Bulgaria. So I prefer to have the United States, where is it? It should be English. English United States. Oh, okay. And then I will use then month and year for the dates. The first days of the week is Monday, and additionally it's by default the dot, the comma format, and I don't use groups for digits, I use space. Digit grouping is with space, but measurements are metric. So I changed my format, and now if I run again, it will be 3.5. So in short, if 3.5 doesn't work for double parse, for scanner dot next double, just go and change your format here, because it's here, the decimal symbol. It should be dot. It's recommended to be dot because this is the most widely used internationally. Okay, so let's go ahead with the next assignment. We need to write a program called greeting, which reads input from the user, his name, and says hello and his name. For example, if we enter John as an input, the corresponding or respective output will be hello John. if we print hello Dave, it will be hello Dave. So I will create a new file called new Java class greeting by name. This is the name I give for my program, which answers what's inside. It's a code, a Java program, which reads a name and puts a greeting by name. So it will be something like double. No, it's not double. It's a scanner. Scan equals to new scanner of system.in semicolon, and then string name equals, but it's with large S, so with capital S. String name is scan.read scan dot next line. I cannot type in my keyboard, and it will say something like s out, system out, print system out, println. Why? What it wants? S out. Something gets broken, but I can type system.out dot println of name, or something like hello plus name, and I can, something happens. I don't know why, but something happens. Maybe I have, oh, what happens is that I don't have the main method. Oh, okay, now everything will work correctly. And I can use now s out, enter your name. It will be print without ln in order to enter your name on the same line, not on the next line. And I need to run this, run. I will stop this in just a centimeters. Terminate, and greeting by name. I will run it. Run. Enter your name. My name is Svetlin Nakov. It says, hello, Svetlin Nakov. And maybe it will need something like exclamation mark at the end. What's your name? I'm Peter. Hello, Peter. It might be like this. Print f with hello %s and /n, new line, with name. Let me check. Enter your name. My name is, for example, Maria Stewart. For example, hello, Maria Stewart. This is how it works. And this is another solution. We read the name with console next line. We print hello. The cursor stays at the same line. We print the name. And this works in a similar way like our examples. The second variant is to use hello plus name. And the third is with this %s here and comma name. Okay. Let's go ahead. This is the concatenation, or putting together one followed by another, called concatenation. So this is another example of concatenation, concatenating text and numbers. If we have three variables, first name holding John, last name holding Doe, and age holding 34, we can combine them or concatenate them using the plus sign. This is not addition. This is not add one number to another. This is concatenation. So it combines several pieces together in a single string, and the result is string. For example, this is the John concatenated with space, then with Doe with space and vertical line and another space, then with the age. This is another way to do it. A plus B is equal to A plus B. This is very interesting. This is string. This is A, this is B. So if A is 5 and B is 11, it will be, the result will be something like A plus B equals to 5, 11. Why? Because this is string. The string plus A is A plus B 5. And together this string with B is A plus B equals 5, 11. So this is not plus. This is not sum or addition. This is not. It is concatenation. The same symbol plus, the same operator plus, can be used to combine strings and to sum. If you want to achieve here 16, we should put brackets. If we put brackets, A and B will be first added and then printed. I will show you this. But let me show you first the first example. I don't want to type it from the 0. So it's John Doe 34. John plus space plus Doe plus this plus H. And the result, oh, it's not greeting by name. Sorry, it should be put here, for example, because I want to keep my greeting by name file holding the solution of the problem called greeting by name. And this is the output. I can print something very similar like this. John Doe of H%D, first name, last name, H. Okay, but it should not be println, it should be printf with a new line at the end. So this will print the same thing. If I want to assign this in a result, see like this, string.result, result again, should be something like string.format. I give the formatting string like this one and the arguments. This is another way to use this. And finally, I print this result again. I can either use printf or println combined with string.format. There is no good way to combine variables with text, like variable interpolation in JavaScript, in C#, in Python. Java is the last language still not supporting variable interpolation, or a good way to do this in a better way. But that's life. Not everything is ideal. The second example is this 5 and 11 and how this is combined. I'll show you this example. Int A is 5, int B is 11. Please print A plus B equals 2, then print A, then print B, and this will print 511. If I want to sum this, I can do it like this with brackets, which will change the priority of execution and will first evaluate this. Or better, in sum is equals to A plus B, and I just print the sum. And this is a better solution, which is also correct. A plus B is 16. Just be careful about this plus. Sometimes it's sum of two numbers, sometimes it's a concatenation of two strings. And if the second is not string, it will be turned into string before concatenation. Okay, the next topic is about arithmetic operators. I already have partially shown you how to use plus or division, but now we'll talk about add, subtract, multiply, and dividing numbers using plus, minus, asterisk, and this slash operators in Java. So adding and subtracting numbers is done by plus. It's a plus b is 12. Subtracting 15 minus 7 is 8. It's very simple. So a plus b is obviously yes, I will rename it Control RR result. It's not Control R, is refactor rename, Shift F6. It will be called result because now it's the sum, 5 plus 11, but if I use minus, it's the difference, and the difference will be minus 6. Okay, it's just like it should work. More interesting are multiplying and division. Why? I'll show you first multiplying. A multiplied by b, 5 multiplied by 6 is 30. Let's see what happens if the numbers are big. It gives just incorrect result. Why? Because of overflow. You should use long here, not int, because long fits bigger numbers. It's still incorrect. It should be like this, but it's complex to explain. You should just use long. Now the result is correct. It's called type conversion, because multiplying ints returns int, but if the result cannot fit in int, it's truncated. It's better just to use long and to be able to use bigger numbers like this. Here, this works correctly. But we will talk about overflows later. Just for now, just imagine that overflow exists. And int is ranged from minus 2 billions to 2 billions. And long has significantly higher range. It's twice as more digits as which can fit in int. Okay, division. If you divide two numbers like 25 by 4, if you divide them int, the result will be int, and the remainder will be just removed. So if we divide 24 by 4, the result should be 6. If we divide 25 by 4, it should be 5, but because this is integer division, it will be just 6 again. Okay, this is how this works. It takes the decimal, only the non-fractional point, the whole, the integral point, part of the result. Okay, so when dividing integer, the result is also integer, like this. 25 by 4, it's 6. But if we divide by 0, it will be an error. See, a runtime error. If b is 0 and we divide 25 by 0, it's arithmetic exception, division by 0. It's error in our program. But if we divide by 4.0, which is double, the result will also be double and will be 6.25. See? When we divide two numbers and one of them is double, the result is double. The result is fractional. The result is non-integer. If both of them are integer, the result is integer. And the interesting thing is that when we divide something by 0 in double, the result is infinity. which is obvious, but infinity is a special number which is just infinite number, infinitely big number. Okay, I will not get into details, this is just how this works. And finally, if you divide 0 by 0, it will be undefined or not a number. None, not a number, undefined, because it's undefined by math. So that's the processor doesn't know what to do. So 15 divided by 2.0 is 7.5. By 0 it's infinity, and 0 by 0 it's not a number. This is something I already demonstrated to you in the latest example. The interesting operator next is this percent. Percent or percentage is the module from integer division. It's the remainder from the integer division. For example, if you have 7 divided by 2, okay, 7 divided by 2, this is 3.5. But 7 divided by 2 as integer is 7 and remainder 1. Do you agree? It's because 7 multiplied by 2, it's not 7 remainder 1, it's 3 with remainder 1, sorry, because 3 multiplied by 2 is 6, plus 1 remainder, it's 7. This is how this works. So this is just the remainder. A% B here is 1. It is the when you divide and when you remove the the integer part, there is a fractional part. And this fractional part before the division, it's called remainder. So it's something like this. A% P is the int part of A divided by B multiplied by P, and this is, sorry, A minus, for example, 7 minus 6, because 7 divided by 2, this is 6, and the remainder is the original A, 7 minus this 6, it is 1. It is the remainder. It's a math concept, so I cannot explain it better than the mathematicians, so it should be you should be familiar from this, from the school math lessons. So 7 is 3 times 3 multiplied by 2 plus 1. It's 2 is the division result and 1 is the remainder. Similarly, 3% 2 is 1. 4% 2 is 0, because 4 is directly divided by 2 without a remainder. The remainder is 0. And 3.5% 1, this is the fractional part. This is a standard way, percent 1, to take the fractional part of non-integer number, of real number. Okay? So, of course, you cannot, I will show you this, you cannot divide by 0 and have percent 0. So int A is 20, for example. A% 5 should be 0, because it's 5 multiplied by 4 is 20. The remainder here is 0. I'll show you. But A% 3 is 2, because 5 by it's not 5, 3 by 6 is 18, plus 2 is 20. So the remainder is 20, because 20 by 3 will be 6. But we have plus 2 as remainder. Now the remainder here is 2. Okay, so interesting scenario is when we have a number like this and we want to take its last digit, this 3. I should print %10. %10 takes the last digit of given number. Okay, %100 takes the last 2 digits, 43 here. See? So this is very helpful property. And if we want to divide by %0, it will return 0. It will return a problem. Division by 0. It doesn't work. So don't use it. And also if we have -20, the remainder will also be negative. This is how it's defined by math. -2 is the remainder here. Okay, so this is how this works. %1 gives the fractional part of given number. That was all about this plus, minus, multiply and divide operators. Now let's say a few words about expressions. Expressions are the mathematical and natural mathematical way to combine values with operators. So this thing is called an expression. But I can make even more complex expression, plus 5, for example. Or I can say 2 times this plus 5. Let's do this. And this is an expression which will be calculated and a value will be returned. So this is something very natural. Expressions combine operators, literals and variables which are related to a value. What is the word literal? Literal is a way to express certain value in your program. So this is a integer literal, -20, or -20. This is also a literal. Let me show you. 000 underscore 000. This is the value of 2 millions. 2 millions, but written in a more readable way. Or it may be int b equals to 0x55. This is a literal which says that the value is in the hexadecimal system. This is a value which is separated by underscores. They are ignored. Int c is equals to 0b, and this is a binary literal. I don't know the value. So we can calculate a plus b plus c, and this is an expression, plus the literal 0b11. And the combination of values or literals with variables, with other operators, with brackets, for example, something like this. This is called expression. So this is how we can organize more complex computations. The result is this. You can check it. yourself. So this is expression consists of at least one operand, which is a literal or a value or a variable, and can have one or more operators, just like this. X plus 5 is an expression. This, the assignment, is also an expression. So let me show you. Like we can print this, we can print if we have int sum, I can print sum equals to a plus b plus c. And this is correct because sum, this equals, this expression returns the right part. So I can say sum is equals to this, and the result will be this, and also the sum will be assigned. So this is a combination of assignment plus returning the result from certain expression. This will print the same things here. Okay, this is another expression. This is called string expression. So the type of the result here is int. But if I do something like text plus a plus b plus c, this will be expression of kind string. So I can print some text combined with this, and this can be summed before combining. So this is an expression of type string, the result of this computation. So expression is a computation. It's string. See the result. This is the result. Okay, and we can have more complex expressions like this. We use brackets when we want to change the order of execution for the calculation of this expression. Like in math. And like in math, the multiplication and division have bigger priority than the others. So something like 1 plus 3 multiplied by 4, 1 plus 2 multiplied by 3 is 6 plus 1, this will be 7. Okay, but if we change the order, 1 plus 2 will be 3 multiplied by 3, like in math, this will be 9. So the same rules like in math for the priority are applied here in programming when we calculate numeric expression. Okay, a lot of things I have given for you today. Working with the console, reading input, reading output, working with int, double, string, using different kind of data types, reading values, printing values, formatting values with placeholder, %s, %d, %f, %.2f, things like that. Now it's your time to play with this concept through the practical coding exercises. You will find these exercises in your online lessons, in your learning platform, and please start coding, because learning of development, software engineering, coding is done only by practice coding. So please code now or later. If you don't code, you are nothing. Just like if you watch someone driving a car, it's not like you to try driving a car. Learning coding is about practicing. Start now, and after a while I will come back and I will show you my solutions to these problems. But first, make your best to solve them yourself. If you have questions, you can ask in the chat and we will answer you, because this is our job, to help you, to assist you, to support you during your learning process. So start. he go, hello again, did you solve your problems? Now I will show you my way to solve these coding exercises, and I hope that you will learn some better way of doing them, or some of them might have solved them in a better way than me. You'll see. So the first problem is called calculate speed. It's about writing a problem to calculate the speed by time and distance. We are given time and we are given distance. For example, for 10 minutes I have run 3 kilometers. What is my speed? If I have the distance and the time, if I divide the distance by the time, I will get the speed. So it's about calculating the speed needed to travel given distance for given time. I need to print the result formatted to the second digit. This is an example. If I have passed 15 kilometers for 2 minutes, my speed is 7.50 kilometers per minute. If whether the first is kilometer or inch or mile, and whether the second is second or minute or hour, it doesn't matter. It's just about to divide two numbers. So it's called speed calculation. I will open IntelliJ IDEA and we'll create a new Java class what will be called speed calculator. What's this? This is a calculator for speeds. Okay, I'll put the main method and I will write here something like scanner equals to new scanner of system.in. Okay, I need to put out enter here to import the class. This created this new line, and now I can read first what's given first. First it's given the distance, then the time. So double distance equal to scanner dot next double. Okay, I will read additionally the time. Double time equals to scanner dot next double, and I will calculate the speed. Double speed equals to distance divided by the time, and I will print it's S out CW. This is in Visual Studio in C#. It's something like speed equals, and I will print the speed. Let me check if I have, oh, not this, run this. Control F5 runs the last problem, the last Java file I have already run, but this is my first string for this class, so I need to run it explicitly. I say something like I have passed 70 kilometers for 3 hours. I should pass 23.333 kilometers per hour. If I run, for example, 20 kilometers for 2 hours, my speed is 10 or 10.0. I can print %.f2 because by design I need to format the result to the second digit after decimal point. So it should be something like this. But if I run this incorrectly, I'll show you. 25, this percentage is printed. I should use printf, not println, and new line, in order this percentage to be used and replace it with this argument. Okay, and now it should work like expected. If I 21 for 4 hours, point, it's not point F2, it's point 2F. Let me test again. I had a bug in the program. 21 for 4 hours. My speed should be 5.25. For 4 hours it gives 21. I believe this program is solved. Let me see the already prepared solution. I create a scanner, I read the distance by parsing the next line. To double, I read the time by parsing the next one coming from the input into a double number. Then I divide the distance by time and I print formatted the speed. Okay, the next program, the next assignment is to write a program which converts from US dollars to euro. Assuming that the dollars come as a floating point number and the rate between dollars and euro is 0.88 euros for $1. This is, we assume the rate is flat. It's not true, but for simplicity. And finally, we print the converted euro value formatted to the second digit. So 17 euros are 96 dollars, euro, sorry. $87 is 76.56 euro. Okay, let's do it. New Java class, and I say dollars to euro converter. This is what I have in this program, dollars to euro converter. I have the main method, and in it I have scanner equals to new scanner of system.in. It was imported. When I press enter, it should be small letter, and I have something like enter USD amount and double US dollars value equals to scanner dot next double without ON, and print, first calculate the euro value equals to US dollars value multiplied by 0.88, because this is what the problem statement says. And now it will print something. You have %T euro, something like this, and the euro value, but it needs printf with /n. Let me check whether this runs correctly. I will run this program by right-clicking over the code and saying run. $20 are T is not double, because this is an integer, %d. It should be %.2f. Let me try again. I use %d, which is for integers, and I put a double value, so it doesn't work. $20 is 70.60 euro. Looks correct. So 17 should be 14.96. Let me check for 17, 14.96. Works correctly. Let's go ahead with the next problem. First, the solution is very similar. We read the first double, we multiply by 0.88, and we convert the output formatted to 2 digits after the decimal point. The next problem is called area of triangle. It's about calculating the triangle area by given side A and the height for that side called HA. So we have side and height. If we remember the formula for triangle area from school, we can calculate the area just by multiplying the side by height and dividing by 2. We need the area formatted to the second digit after the decimal point. If we have 5 by 10, it's 25.00. If we have 3 by 10, it's 15.00. So area of triangle I will copy this because I will need it. I will create a new class called triangle area, for example, or triangle area calculator. I'll use the main. Then I have this. Then I have double size. I just used this from the clipboard. Equals to scanner dot next double. I have the size. I will copy this one and hide. I read them and I print with printf some value percent point to f, and this will be the area, and the area will be double area equals to size multiplied by height divided to 2.0, or divided by 2. It will be the same in both cases. Some of the arguments of this division are of type double, so the result will be double. It will be double of division. Let me check whether this works. It doesn't work like I expected, because area, it was just printed by mistake, and I don't need area. Now it's correct. So I run this and let me check whether it works correctly. 5, 4, 10.00, 3.40, 3.55, 3.75. It's something like this. This is how this works. This is the area, triangle area calculator. The solution here is very similar as the first solution to have the area here, or a shorter solution but less recommended to have this here. Why the second solution is less recommended? Because it's more hard, it's more complex to understand what happens. It's obvious here that we calculate the area. It's obvious. It's obvious here that we print the area. But it's not very obvious what exactly we print and what exactly we calculate, because we don't have a variable called area, which explains that this is the area and this area is calculated by some formula, things like that. So the first solution is highly recommended to the second, because the second is more complex. It's shorter, but it's more complex, and this is not good. Good developers, strong developers, best developers write simple code. Bad developers, they think they are very clever and they write complex code, and after a few months they cannot read their code as well. They cannot themselves read their code. So don't write complex code. Use good variable names, use good class names, use simple sequences of comments, simple statements, not complex expressions. This is recommendations from the experts, and good developers know this very well. The next problem is called for operations. It just reads two numbers and print their sum, their difference, their multiplication, and their division, like this. If you have 5 and 10, we print 5.00 plus 10.00 equals 15.00. Okay, I will take these two lines, I will need them, and we'll say, please for operations, please create this class, put in it the main method, use this, import the Java util scanners, I use the clipboard, and I'll have first and I'll have the second input, and I will print something like the first percent point to f plus the second equals to third, and we have this first, this second, and this first plus second. Let me check whether this works. Oh, it should be print not println, with the new line here. Let me check whether this works. Okay, 7 plus 5 should be 12. 7 plus 5 is 12. Okay, the others are exactly the same. I copy this 4 times and say minus multiplication, and here I have division and division. And let's check what happens. If I have 7.5 and 2, I have 9.5 books correctly. So I'm ready with this problem. This is the solution which was prepared, num1 and num2, and it's even nearly the same. So %n means new line, and /n also means new line. Sometimes it might have differences, but let's not get into these details. So I already have shown my solution, so let's go ahead with the next problem. The next problem is called days to minutes. I want to write a program which reads a number of days and tells me how many minutes are these days. For example, 5 days might be, this is an example, 2 days is 2,880 minutes. I read an integer and I print the minutes, which is another integer. 5 days is 7,200 minutes. Okay, days to minutes. I create a new project here, a new Java file. Days to minutes. It's recommended that you have one project per each lesson. For example, in our training course called Programming Basics, we have several lessons. Intro to Programming was the first lesson. Calculations examples is the second lesson. The next lesson will be conditional statements. And for each problem, we solve many problems. You should have one Java file. This is a good way to structure it and also have a good names, readable names. For example, what is square area calculator? It's something which converts from inches to centimeters, or something which prints a triangle of stars? No, it's clear what is it. It's something which calculates the area of given square. So let's continue with the days to minutes. I have main, I have in the clipboard, not the correct thing, but I will go here to take this line of code and I will return back here because I don't like to enter this code so much times. Next I will read the days. Int days count equals to scanner dot next integer. Okay, then I will say how many hours hold these days, and hours equal to days. Each day has 24 hours. And how many minutes are there? Each minute, each hour holds how many minutes? Exactly 60. This is how our clock works. So if I print the minutes, there will be something like this. Let me check whether this works. I run and I say that I have 5 days, and in 5 days I have 7,200 minutes. It's like this, so I assume it's correct. I read the days, I multiply by 24 and obtain the hours. I multiply it by 60 and obtain the minutes. And finally I print the minutes. Very simple program with 4 lines of codes, with 4 statements, 4 commands. I can print it like this. Another solution is to be something like, let me take the calculator, 24 by 60. This is also a valid solution, but it's bad solution. It's an unreadable solution. It's correct, but it's bad. Why? Because what's this? Why it's not 1740? What's this? You are unable to know what's this. So the best way to do this is like this, to have different steps. The first step is to read. What I read? I read the number of days. What next I do? I calculate the hours for these days. What next I do? I calculate the minutes for these hours. What's next? What I do? The next thing is to print. So please, when you write code, write it like this, with a long number of small steps, small, obvious, understandable, readable steps, simple steps, instead of small number, complex steps. This is disaster. Don't do it. Okay? The next problem is called circle and area and perimeter calculator. You are given the radius of a circle, 14-point number, a double number, and you need to calculate and print the area and perimeter of the circle formatted to the second digit. This is an example. If we have 7, the area is 153.94. If we have the perimeter 43.98. Okay. Circle, area, and perimeter. It's obvious how to name this new Java class. Circle, area, and perimeter. This is what's inside. What's inside this program, this file? It's something which works or calculates circle, area, and perimeter. Perimeter. Shift F6. I have bug. Perimeter without DC. I should delete DC. Delete, enter. So here it was changed. Here it was changed as well. This is what to do when you have mistake, when you have bug. Main. And now what I have, I'll take these 2 lines of code here. And I have double radius dot next double, and next I will do the calculations. Double area is equals to p by radius by radius, pr square. This is the formula for circle area. If you don't believe, just open a web browser like this, for example. Here, perimeter formulas. Circle area and perimeter formulas. And this, if this is the radius, the area is p by r by r, and the perimeter is 2 by p by r. And what is p? What is p? P is this constant. This p. If you have never been in school, it will be complex for you, but I suppose you have been there. Okay, so how to get this p? We can just take it from here, Control C, Control V, and double perimeter is 2 by p by the radius. Finally, I can print area equals area and perimeter equals perimeter. Run this program, and I have a sample data here. Wait, where is 7? Okay, if it is, I told you to run this program, what happens? 7. 1.3. Oh, I should have this percent point to f. Percent point to f slash n and print f instead of print len with the comma. This is how this works. Run it again, and now I have 7 radius, 153.94, 43.98. Okay, but this is ugly. This is something I need to remember. If you do another search on internet, like P in Java, you'll find how to use P in Java. And it is something like, do you see? math.p. Let me try. math.p. Looks like Java knows, has math.p, and Java knows how much is the value of p. So I just put it, run it, and if I enter 7, the result should be exactly the same. It is, this was entered by me by mistake. Okay, so this is a better solution. Let's see what I have had in mind before starting to solve these problems. Exactly the same thing. I read the radius, I calculate the area by multiplying math by p by the radius again, and this math p constant is this one. It's already known by Java, I don't need to remember it. The perimeter is the other formula, 2 times p by over the radius, and I print again. Yes, looks correct. Here I use this percent n for the new line, or it might be slash n, but this is these are details. Okay, the next problem is called person info. It's about writing a program which reads info about a person and prints this info in a structured way. Like it reads the first name, the last name, the country, and the town, 4 strings. Okay, and prints in this format. This is the example: Kelly Smith from Ireland, Cork, or Svetlin Nakov from Sofia, Bulgaria. I will write this person info. Add new class. This is person info. I will use Control Tab to take this line. We'll return back main. I will increase the font in order to simplify you when reading and watching the video. Okay, and next I will say something like, what is it? First name, string, first name equals scanner dot what? But next line. Please read the next line. First name. I will copy and paste this several times. Last name, first name, last name, then country, then town. And I need s alpha solve is printf slash n. It's something like Peter Quark from %n Sofia, from country dash town, and I print the first name, last name, then country, then town. Enter. Let me check this. I'll take this Kelly Smith, paste. It's pause. It's not paste. Control V, paste. Input mishmash. Next one, next one, next one, next one. Maybe I need to write this because copy paste doesn't work. Svetlin Nakov. Oh no, it doesn't work. First name, input mishmash. Why? At which one? Ha! Next double. I'm running different problem. So it should be person info. Run this. So I was testing different problem. Kelly Smith for iron cork. I don't have this exclamation mark at the end. Let me test again. I fixed this bug. It started, Control V. Kelly Smith for iron cork. Works correctly. So I have the solution, and this is another way, which is exactly the same, exactly my solution. So the next problem is called town info. It's very similar. It reads name, population, and area. 2 integers and 1 string. And it says the town of town name has population of population name and area of area square kilometers. Just like this, town info. It's very, very similar. I will take this. I can copy this file. See, I take this file, Control C, Control V, and I will use town info. It's not, sorry, it's not person info. It's what? Town info. It's correct. So I created a copy of my previous program. It's called town info. It reads name, population, area. Name, 10 int population. And if I say next int here, I might get into trouble, but let me check. Area, next int, and I print something like the town Berlin has, oh, I can do this. It's easier. The town Berlin has, copying from PowerPoint doesn't work as well. The town as, which is name, Shift F6 is town name, in fact, population of %t and area %t area, and this is what I have, and I don't need double slash n. Let me check, run, and I will print this as input. Control V. Berlin has this population, this square kilometers. Works correctly, so it works. But if it is like this, first the population, area, and then the town name, it will not run. We'll see. For example, this is the population, the area is this, and the town, do you see? It doesn't work because this is the problem. Scanner next one fails if you use next int and next int. In short, you cannot read string after int using the scanner unless you use only next one and integer dot parseInt. If you use this approach, it will work all the time, but it's more complex and more wonk for writing. So if we have this population with this area, the town of Sofia, for example, works correct. So please be careful, and this is our solution. Okay, let's go back here. This is an example how to read the population area and the town name and how to print the required output. So this was our WASP problem, and I'm happy that today I have shown to you how to use variables. You already know that variables hold some data in the memories. Variables have data type, which defines their data range. For example, integers from -2 billions to 2 billions, this is the type int. Bool is the type which holds either true or false. Local date is the type which holds a date. String is a type which holds text string. Statements define commands, like assignment statement, like method invocation statement, like object.actions, brackets, some parameters, and things like that. We have written many statements. Developers write statements. This is their jobs, software engineers or coders. Reading inputs in Java is done through the Java util scanner class. You write Java scanner scan equals to new scanner brackets system.in. Later you say next int, next double, next line. We know simple operations like plus, minus, multiply, divide, percentage, which is a reminder calculation, reminder of the division. And we know that we can combine this into expressions, and we can format to 2 digits after the decimal points using this %2f. And we know that expressions combine data plus operators. This is what we have learned, but this is the theory. The practice is learned only one way. Solve your problems. Please solve the problems that even if I have shown you the solution, code it yourself. It should run in your hands. Otherwise, you'll never become a developer. Developers write a lot of code every day. Hundreds and even thousands of lines of codes every day for years until they reach a beginner level and start a job in the software industry. And after that, they continue to do this for many years and to enjoy their good, nice, modern job, which brings them a good standard of living. If you have questions, please ask here in the chat in your learning platform, or ask later in your Facebook groups or in other community forums that you are already aware of and I believe you have joined. So goodbye from me. I will see you maybe the next week or for the next lesson. Bye bye.